welcome back, finally, to the Centurion Minicomputer. It's been a while since the last episode. I believe the last one aired in October-ish, and a lot of people have been curious what's been going on with the machine. So today I want to give y'all an update. But between October and today, there's been a ton of new people joining the channel, so thank you guys so much for joining. Welcome. But some of y'all may have never seen this system. You may be wondering what on earth it is that you're looking at. Well, there's, I believe, 7 previous episodes in the series where we go into pretty big detail about all of the individual components that you see here. But if you don't want to click away from this video, I totally get it. So I'll just give you a quick rundown on what it is you're looking at. And about a year ago, I saw a Facebook Marketplace listing for a Centurion Minicomputer. The price was so mouthwateringly good that I couldn't pass up on it. So we hopped in the truck, ran up to Muskogee, Oklahoma, loaded up almost everything you see here. There was one extra chassis, and I don't believe that the printer is in the shot, but it's right back there. It weighs a ton and doesn't really move very easily. But we loaded all that up, brought it back down, and tried to take stock of what it was that we had. And then over the course of the next episodes, we tried to look a little deeper into what exactly this computer was, because it didn't seem to share anything with the more well-known mini-computers of the era. We dumped the ROMs that were on the CPU and computer boards down here, and we took a look at the actual CPU boards themselves, all of the computer boards, and we took some guesses at how it would work, and I think we missed it quite a lot on some of them, but I have since gained some extra information. But we finally hit a brick wall when we tried to power it up and get it to talk to the terminal. Now, I did receive 3 terminals with it. These 2 cleaned up very nicely. I haven't touched this one because it was in very rough shape, but when we powered it up, tried to get it to talk to the terminal, nothing really happened. So we ended up probing one of the ROM chips on the CPU board down here, and we saw some activity, but I didn't really know where to go from there, because everything in here is proprietary Centurion. Even all of the microcode on the actual CPU board is proprietary Centurion microcode. So looking through the ROMs doesn't really yield any useful information. And so I kind of came to a halt, and there haven't really been any updates since then. However, there was a very kind gentleman that started providing a huge amount of information that was unavailable anywhere, and I got super curious and reached out to him, and it turns out he used to work at Centurion. He was the 6th employee, or the first employee that wasn't a family member. He was there from the beginning, very nearly, and he knows the entire story of the company, and it is a fascinating story. There is, I mean, you can make a movie out of it. There's car accidents, there's fires, there's all sorts of crazy corporate shenanigans going on in the background. It's unbelievable. And I really want to tell that story, but this is not the episode that's going to happen in. I'm kind of building up to hopefully make a Centurion mini documentary to preserve the history of this insane, awesome company. But you're here for the computer itself, and we did see some activity on the computer, but we've learned a lot more since that last episode, and I want to update you guys on what's going on. So I'm going to bring the camera in, we're going to zoom in real close and go through the computer, the terminals, the drives, and give you a full status update on where we are, and then we're going to talk about where we're headed in the future. All right, here's the actual computer itself. It's in the bottom of the primary chassis, and it's just composed of these 9 individual cards. And going from left to right, we have the CPU 6 card here. A little bit of information about this. It's called the CPU 6 because originally the very first Centurions were called the CPU 4, and that's because they used 4 boards. They had 3 boards for the CPU and 1 board for direct memory access. And then they combined all of that into the CPU 5 board, which took up 2 slots. And then finally that evolved into the CPU 6 board that we see here, which takes up only one slot. This is a multi-wire board. This is essentially an 8-layer board. It's a little ridiculous. You start with a fiberglass board in the middle, then you have a ground plane on one side, a power plane on the other side. Then there's a full etched PCB on top of that and below that. And then they do the multi-wire, where they essentially run 2 layers of enameled wire to make all the connections, and they do that on both sides. And the CPU 6 board and the CMD board over here both utilize this multi-wire technique, and they are extremely complex. Now, I had mistakenly guessed that the CPU 6 and the CMD board worked together to kind of give a 16-bit architecture because it uses the AM2901 4-bit slice ALU, and there were 2 per board, so I was kind of going, 16-bit. That's totally incorrect. The CMD board is just used for input-output control, notably to the drives, and then the CPU board is, well, the actual CPU. Now, the disk AUT right here next to it and the disk 2 card, these are for controlling the different disk drives. Now, the exact interaction between these two and what's going on, I don't really know. It's kind of beyond me. The next 2 boards are the MUX boards. These are our serial outputs. One of these is a primary, one of these is a secondary, and you can get different baud rates out of them. But the primary one that we're concerned with is going to be this one right here. This is port 0. This is where all of the basic communication is going to go through. Next to that, we have the printer card. This is probably the simplest card in the entire machine. It's just for controlling the printer. It just sends 7 bits out, receives 4 bits back to tell us if, if the printer's out of paper or if it's ready or whatever. And then right next to that, we have our 2 memory boards. I'm working from memory, but I believe that it's 128K, 128K for a total of 256K of memory. But none of that really matters because every time we turn it on, well, we don't really get any communication going on. But there is some interesting stuff happening on the MUX card here, and I'll show you. I've got one of these little breakout RS-232 things, so we'll go ahead and plug that in here. And I've got the scope set up, and right now the scope is reading off of the DSR pin, I believe. But if we turn it on, look at that. The dataset ready pin is trying to do something. So we have actual data coming out of the MUX card, which means that, well, the computer is trying to talk to a terminal. That's good. So if we plug the terminal in, which I've got right here, that pin goes dead, but nothing communicates with the terminal, so we're kind of dead in the water. But every time I push the select button up here, I see a little flash on the one of the LEDs down here, which tells me that it's trying to send something. So if I move my jumper over and we take a look at the scope, if I push this button, there we go. Did you see that? So we can see that it's actually trying to send some information. Now the pin it's trying to send on, I believe, is the RTS pin, which I'm not really sure if that's correct, if that's what's supposed to be going to these terminals or not. But hey, at least it's doing something, because when I push the select button up here, the CPU card is interpreting that, making a decision, sending a command to the multiplexer board, and the multiplexer board is outputting from there. So the computer, I believe, is pretty close to executing code, which is awesome. But our terminal isn't displaying anything, and we can't get anything from the terminal into the computer, and that leads us to the next problem, which is issues with the terminal. So here is the terminal. We took this apart in a previous episode and gave it a properly full restoration. It looks brilliant, and it appears to be working. Right now it's in full duplex with self-echo on, and if I type, it seems to work no problem. It prints whatever it is that I type on the screen. Now it has self-echo on, so that is expected. But if I turn self-echo off, we get some interesting behavior. So now self-echo is off, and if I type, well, we don't receive anything. And that is expected, because full duplex is supposed to transmit whatever I type out, and it's waiting for the computer to echo it back. But if I change it to half duplex, well, whatever I type should go up here, right? So now we're in half duplex. I can see it says send here on the bottom, but whenever I type, nothing shows up. Okay, so let's go back up to full duplex. And now I can see on the bottom here, it says send and receive is flickering, like maybe it's trying to send and receive at the same time. If I type, well, I don't get anything, and then all of a sudden it says keyboard lock and receive only. Send has completely disappeared. And the only way to get it out of this is to power cycle it. So we'll power cycle it right quick. That'll bring us right back up to the screen here. And well, now it's like it was before. I can type and nothing happens. So the next obvious thing to do is to short the transmit and receive pins. So that way, whenever this transmits something, it immediately circles back around, comes into the receive, and should be printed up here. If I type, well, nothing happens. But it's not saying send or receive down here like it was when we toggled the full duplex, half duplex. So let's try toggling that and see what happens. All right, now it's flashing send and receive down here. And if I type, well, now we're in the same problem, except my cursor has jumped all the way down here to the bottom. It now says receive, keyboard lock. For some reason, the cursor's down here, and I don't know. I don't know what's going on. But it's going to require coming apart and getting looked at in more detail. Now, the other two terminals both have issues as well. So we're going to need to sit down and do some proper work on all three terminals, and maybe we can get one of them functioning correctly. So with coming to a halt on the terminals and the computer itself, we shifted our attention over to the drives. And, well, not great news over there either. All right, we'll start with the Hawk drive, and Mr. Romaine's specialty was actually in this Hawk drive, so he was quite keen to get it apart, and well, he saw it and said he's never seen a Hawk drive as rough as this one. Now, I haven't done anything with this Hawk drive since I pulled it out of the system. It was just in very, very rough shape to begin with. We knew that the heads were absolutely decimated, but those were the heads for the removable platter. But this made us very worried that there might be a head crash on the fixed platter. So Ken got to work removing this black outer case, and I've left all the screws out so we can just lift it out of the way here. And we were greeted with a very, very crashed fixed platter. We went ahead and removed it, and normally you would never want to do this because it misaligns it, and well, it makes it totally unusable, but well, I mean, you could see it's totally unusable as it is. The head crash on this was so severe, it's just totally ruined the heads and the disc. This is ridiculous. And this was not done by us because we've never put power into this machine. Well, the disk never had a hope of running, and well, this is a big problem because the only copy of the operating system was on this disk, and well, that's gone now. So that makes some issues, but we'll talk about that a little later. So maybe this one will be a good candidate for somebody else that is restoring a Hawk drive, but I don't think it'll ever come back to life on its own. So next, on the Phoenix drive, we were worried that it might have had a head crash as well. So we took it apart too, pulled the top off there, and then there's a little plate here that gives us a good view of the platters, and sure enough, there's a head crash down here as well. And so, well, whatever data was stored on the fixed platters is gone on both of these drives. And honestly, that was more important than the drives themselves. Now, this Phoenix drive could be restored. You can take, there's actually 3 fixed platters in here, but you can take each of the platters out and take platters from some of the removable discs and replace them, replace the heads, rework the cooling system so that the heads will properly fly over there and they won't crash anymore, and it would be a working drive. But seeing that it did have a head crash, we weren't too worried about putting some power into it. So we put it back together and we fired it up just a little bit to see if the heads would move. And they did move. So electrically, this thing is working perfectly. It's just that the heads are crashed. And that was something that I was, well, maybe kind of expecting. Both of these drives were used for many, many years. And as a matter of fact, these were used all the way up to December of 1994. And a head crash was really not something that surprised us because we took a look at the air filter. So to look at the air filter, we've got to lift this cage up and over. It slips out of the way. I've already removed the bolts here, and then this whole thing lifts up like the hood of a car. Now the filter itself is right here. It can just be popped right on out, and then we can take a look at the date that it was changed, and it says 11/20/89. You're supposed to replace these air filters every year, and it was used for an additional 5 years after it was replaced, and that was a bad idea. And it smells horrendously of smoke. So this was used in a very smoky environment, and the air filter was never replaced. And the air filter is paramount to keeping the heads from crashing into the disc, because the heads actually float on a cushion of air. So I think probably what happened is they were using it, they didn't replace the air filter, and finally it got so disgustingly clogged up that the heads crashed into the platter and made the whole thing unusable. So all hope is lost. The operating system, which is completely irreplaceable, was on the fixed platter of the Hawk drive, which had a head crash so severe it completely destroyed the platter, and all of that was years before I ever got my hands on the system. And without the software, well, the hardware is not really going to do anything. And it gets even worse than that, because the AM2901 is a wonderful ALU chip, and I can actually look up what the opcodes are for it, but those aren't the opcodes for the machine. The machine itself is actually emulating the older TTL architecture that was built for the early Centurion computers. The AM2901 is just part of that emulation hardware. So the actual opcodes are a total mystery, which means we can't even write new software for it. So, this is the end. Or is it? You see, I'm sitting here today thanks to one man, Mr. Romaine. Mr. Romaine reached out to me. He used to work at Centurion, and he showed up here with 50 years of knowledge, know-how, and experience. And that is indispensable. But he had a trump card up his sleeve. And he pulled it out and showed it to me, and it was this little board right here. This is our glimmer of hope. And I feel a little nervous actually holding it, because this holds the future of this machine. This is a PROM diagnostic board. He calls it the PROM Diag board. And it was built for the technicians and engineers to diagnose and repair Centurion computers in the field. Because, well, when your computer weighs this much, you can't send it back to the manufacturer comes to you. And they only made about 50 of these boards. And that may sound like a lot, but they made over 1,000 of the machines, and this is the only surviving one I've ever seen. So to have 1,000 come down to just one, for there to still be a diagnostic board floating around when they only made 50 is unbelievable. Now, what makes this diagnostic board so special is that it has several different diagnostic programs saved in the 4 ROMs right here. The first diagnostic program is incredibly simple. It just tests the power supply. And then the next diagnostic program goes one step a little more complex. And then the next program goes a little more complex after that. And you select the different programs using the dip switch on the front here, and it gives you the results of the diagnostic program on the 2 LEDs here. Now, we did plug this in and try to give it a shot, but the LEDs aren't displaying anything. So there is something wrong on this board. And, well, it's been sitting in his closet for 40 years, so that's not entirely unexpected. I can see some of the 7400 series chips down here have very rusted pins on them. So as long as the data on the ROMs is still valid, we can fix and repair everything else. And the data on the ROMs being valid is the most important part, because well, the diagnostic stuff sounds rather boring, but the final diagnostic program that's on here is called TOS. TOS stands for Test Operating System. And it's not a full-fledged Centurion operating system like the one that we lost, which is a massive shame. That is a huge loss to the history of computing. TOS is an actual operating system. It allows you to type in a memory address on the terminal, send that to the computer. It will then return and display what the contents of that address are, and then you can change the memory in that address. And if you can view, change, modify the memory, that is a computer. So we have a glimmer of hope in this board right here as a hidden diagnostic operating system. And from that, we might be able to figure out what some of the opcodes are, and then we can start creating new Centurion software to make use of this hardware. Now, there's about 9 million things that have to go right, and the very next episode could be me saying that the ROMs on here have lost everything, or this could be the last episode. I don't know. The future of the Centurion computer is shaky at best, but there is a chance. I'm telling you, there's a chance, and I'm praying to the computer gods in the sky that the data on these ROM chips is still valid. But we're going to figure that out in the next episode, when we pull these out and dump the contents off of it and try to get this ROM board working again. That's our last and final hope. So if you pray to any computer god, start praying now, because I hope this works. But we'll find out in the next episode. I want to thank you guys so much for watching this episode, and I want to apologize for it being so long since the last update on the Centurion, and hopefully there are many more updates to come in the future. But in the meantime, I'm going to do the very terrifying job of dumping the ROMs, and hopefully there's some good information on here. So thank you guys so much for watching, and I'll see you in the next one.